Okay, so just a quick look at the significance of multiplying by a complex number. Now let's imagine ourselves a complex number which we'll call z equals a plus bi, and I'm just going to let here a be bigger than b. Okay, for a really complete proof of this, you'd actually test this with b bigger than a and also with a and b being equal, but it's enough really here just so you can get the idea. Okay, so we're going to do a couple of things. First thing I'm going to do is I'm going to multiply z by a few different things. Now there's an example in your textbook that does this too, and actually has a concrete example with numbers in here. This is just a sort of more theoretical one. The reason that I do this is because you'll often find that you get theoretical type questions in your exams for complex numbers, so it's good to work with sort of more general complex numbers. So the first one I've done here is I've multiplied by -1. I've multiplied z by -1, and you can see what that does is it changes the signs of the complex number. If I multiply z by I, what you'll see, this is a complex number that I'm multiplying by now, is I'll write it out as a bracket, so I outside of a plus bi. We're going to expand through here, so I'm going to have ai plus bi squared. Now remember, the key thing is that I squared equals -1. That's a really important result that you want to use in a lot of your complex number simplification. Okay, so because we know that, we've actually got here I squared, which is -1, so this is ai minus b, okay, because this is really b and that's a -1. So just writing it out in a sort of nicer look would be -b plus ai. It's always a convention really to write your complex numbers out with the I part second. So we've got -z, what that's equal to, so -z equals -a minus bi, and we've also got iz, and I'll just draw boxes around these, I times z, which what that does is we actually find that it swaps the a and the b from being real and imaginary, swaps them around, and it also changes the sign in front of the b. Now the next one, or last one we're going to do, is just multiplying -i by z to see what happens, and when we graph them, we'll actually see the different patterns that occur here. So, multiplying that out, you've got -ai minus bi squared. This time, because you've got a negative in front of an I squared, which is -1. I squared is -1. This is now going to be positive b minus a times I. So that's -iz. Okay. What we're going to do now is actually have a look at what happens in these three different cases, starting with this original complex number. So let's sketch these down. We've got a is bigger than b. I'm actually going to work here with a and b being positive numbers, okay, just so that it's sort of a bit easier to sketch. So, and you know what, for a, let's just say roughly that a is double b, just for the sketching that I'm doing. So I'm going to put b here and a there. So if we have a plus bi, that would be my a, b, b, a. So you can do this, with actual numbers as well, or changing this around, seeing what happens, just to give an idea of what happens when you multiply. So we've got the imaginary and the real. So let's do a plus bi, that would be there. So that's z. Okay. -z would be -a minus bi, so that would be here. Now what you'll notice about those two numbers compared to each other is that they're actually, lost all my colours. They're actually a straight line away from each other. And if you think about starting at z and where -z is, it's actually going to be rotated 180 degrees away from z in exactly the same amount of space, so the same distance from the origin, but it's going to be rotated 180 degrees, so that's where -z is. Okay. If we look at the other complex numbers, we'll look at maybe a different colour, blue. If we look at iz, okay, and that's -b plus I, -b plus ai, that would be up here, that's iz. What you'll notice here is that the complex number that you're looking at, iz, actually has been rotated, but this time it's been rotated around 90 degrees counterclockwise from z. So it's a 90-degree rotation. So this is 90 degrees counterclockwise. This is a 180-degree rotation. And you can probably guess with negative iz where that will be. That's going to be b minus ai, so it's down here. And you can see that that complex number has been rotated 90 degrees clockwise. So you've actually got different rotations here that happen when you're looking at complex numbers. So multiplying by an I or by a negative I, it rotates it either 90 degrees counterclockwise or clockwise, depending on the sign. So negative I going down this way. And if you're multiplying by a negative one, what that does, it rotates your original complex number 180 degrees from where it originally was. And this is a really nice thing that we're going to see later on when we look at roots, this kind of pattern where you will see complex numbers equally spaced from one another. So that's the geometrical significance of multiplying by complex numbers.